Hello everyone, I'm Ziad Malim from SOMA Academy, and today I'm going to show you how to find the derivatives of functions using the product rule. So if you have a function which is equal to the product of two other functions, in order to find the derivative of this function, in this case h prime of x, you have to use the rule. Take the derivative of the first function, multiply by the other function without taking its derivative, and then adding that to not taking the derivative of the first function and then multiplying with the derivative of the second function. In this case, we have h of x being equal to f of x times g of x. So in order to find h prime of x, take the derivative of f of x first, then multiply with g of x, then add that to f of x multiplied by the derivative of g of x, Okay, let's do an example. This will be much easier when you have an example. Say we have a function h of x is equal to x cubed multiplied by x to the power of 4 plus 10. Okay, and we want to find h prime of x. So in this case, you can always expand this, multiply x cubed with everything, but in order to just show the idea of using product rule, I will assume this as one function and this as another function. Okay, so in order to find the derivative of h prime, we first take the derivative of the first function. So what is the derivative of x cubed? That will give me x, 3x, bring the power down, reduce the power by 1, that is 3x squared. Leave the second function as it is, x to the power of 4 plus 10, then add that to, leave the first function as it was, that's x cubed, and then multiply with the derivative of the second function. The derivative of x to the power of 4 plus 10 is, bring the power down, 4x, reduce the power by 1, that is, it becomes 3, because 4 minus 1 is 3. The derivative of a constant is just 0. So that is what you have. So let us just make this a bit cleaner. 3x squared times x to the power of 4, that will give me 3x to the power of 6 plus 3x squared times 10 will give me 30x to the power of 2 plus, what do you get here too? X cubed multiplied by 4x to the power of 3, that gives me 4x to the power of 6. You add the powers, okay? So what that will give me is that you bring like terms together, you add those two, that is 7x to the power of 6 plus 30x to the power of 2, and that will be your final answer for this problem. Okay, if we could just multiply all this and then take the derivative, this is also what we would get. But just to illustrate the product rule, I treated these two as two different functions. Okay, let's do another example. Say we have a function y is equal to x to the power of 5 sine x, and we want to find y prime. Okay, in order to find y prime, here what you have is you have two functions. One function that is x to the power of 5, and then the second function is sine x. So if we treat this as our f of x, and this as our g of x, what we have to do is first take the derivative of the first function, which is x to the power of 5. So that becomes, bring the power down, 5x to the power of 4, because I have reduced the power by 1. Keep the second function as it is. Then, okay, in this case, keep the first function as it is, x to the power of 5, and then take the derivative of the second function. So the derivative of sine x is cos x. Okay, so that will be your final answer, because there is nothing that are like terms that you can add. Okay, so generally take the derivative of the first function, multiply with the second function, and then add that to, this time keep the first function as it is, means don't take it as a derivative, and then multiply with the derivative of the second function. Okay, let me do one more example. Say I have h of x, this function, as x squared e to the power of x, and I want to find the derivative of h prime of x. Okay, so it is the same. We have two functions, x squared and e to the power of x. What we have to do is we take the derivative of the first function, that is 2x, keep the second function as it is, e to the power of x, plus keep the first function as it is, that's x squared, and then take the derivative of the second function. In this case, e to the power of x, when you take it as a derivative, it remains the same. It's just the derivative of e to the power of x is just e to the power of x. Okay, so that will give me any like terms here. Yeah, there is e to the power of x that is common. I can only factorize it. I can say e to the power of x out. Here you will be left with 2x plus here would become just x squared. Okay, and that will be the answer, but you can as well keep it as it was this way. I hope this was helpful. I will stop it there for today. Thank you for watching. Please do not forget to subscribe. Until then, happy learning.